Hey everyone, welcome back to another video. In today's video, I'm showing off a movement component I made in Unreal after following some tutorials. Alright, so the way it works is, let's just play through it, is we got this statue here, and if we collide with the statue, it will start moving until it gets out of a certain range of us, and then it will move back to its starting spot. So if we follow it, we'll see it keeps moving until it reaches its end destination, and then it will come back and we can move away. But if we just like tap it and then fly away, it instantly comes back. And we can see that it has two ranges. The first range where when we collide with it, it'll start moving, and the second range, it will start coming back. And that if it's already started to come back because it's reached its final destination, us moving away doesn't do anything. So I can show you the blueprints of this. So here's my statue. So we got, when we begin overlapping with this interior box, this one right here, we cast to the pawn, which means we cast to the player, and if we can actually cast to it, we enable movement, which is a function in this my move, which is a C++ component I made, and we say it can move, we give it its reference, and then we set should stop equal to false. And when we end overlap, we pretty much do the opposite. We still cast, but we set move direction to be reverse. It's another function, and then we say should stop is equal to true. And then down here, we have a custom event I made through a delegate in the C++, and we pass a function in is top end point as a boolean. So if it's not, which means we're not at the top end, and we should stop, so up here, then if that's true, we enable movement and we set it to false, and then we reset the movement. And in the, I'll save this, in the C++, we can see, so let's begin play, we set move enabled, or we set the tick function to be ticking equal to move enabled, which is usually true, and then we can enable movement, which sets both can it move and whether it ticks or not. So that's just a performance thing. But inside here, each tick, if we're in reverse, we move the move offset norm. So the move offset is where the final destination is, and then we normalize that as a vector times delta time times the speed, and then -1f, which is -1 if it's reverse, otherwise we just do it normally. And once we get to the endpoint, right here, we set reverse to true, and then we broadcast on endpoint reached equals true. And once we get back to the starting location, we say on reverse is false, and we broadcast false. And then every tick we add to the relative location this current distance. If we go back here, we can close this out. We can click on this statue and we can go my move and we could change them. So let's say we didn't want to move that way, but we wanted to move 500 to the left. Let's just go like 50 there and 100 up. So it'll still work the same. We could even change the speed, so let's make it twice as fast, since this is all modular. So now if we run into it, see we're going up that way, and if we follow it, we're going to go all the way up, and then it will come back down. So we can see we can control which direction the movement goes by setting this in here, by setting the move offset to where we want it to move. And this is relative to this. So if we slid this over a bunch, it would still work. See? So this move offset is relative to wherever its starting location is. Then we have the move enabled, which we set by true just in the blueprint, if we can see. Or where is it? Yeah, in the blueprint we set it to true. So this one doesn't matter too much for individual ones, but it's more just for the blueprints. And then we have the speed. And yeah, that's all I wanted to show you in today's video. Thanks for watching, and click here if you want to see a regular C++ video I made. Bye.